Okay, yesterday we discussed about TLM ports. Right? So it is used to communicate between the two components. That means to transfer the transaction between one component to another component. We are using this TLM transaction level modeling. So here we are using methods to transfer the transaction. So where we are using the method, that is we can call as API. Okay. So there we have to declare the ports, and in another component we have to declare the implementation port, that is nothing but a export. There we have to write the implementation of the method which we are going to use in the actual component. So we saw how to connect the ports, that is port and export, in the top level hierarchy. By using dot connect method, we have to make the connection between the port and export. Then we saw about TLM FIFO. So TLM FIFO is used when the transmitter and receiver is not operated at the same speed. Okay. So we have to use the TLM FIFO so that we do not miss the transactions. Then we saw about analysis ports. So why we go for analysis ports? From one component to, we have to transfer the transaction for multiple components. We go for analysis ports. So now today's class we are going to see about UVM factory. So here we are going to see what is a UVM factory, why it is needed in UVM, and how to register to the factory, and how to create a component using factory, that we are going to see now. So UVM factory is a class which used to create UVM object and UVM component during the runtime. So you know, right, what's the UVM object and UVM component. So for example, sequence items, sequences, okay, these are UVM objects. So it is transient in nature. But the UVM components are UVM driver, UVM sequencer, UVM monitor, UVM agent. These are all called UVM components. During the runtime, they are created, and throughout the simulation time or runtime, it will be static. So these are called UVM components. Those things we are going to create by using UVM factory. To enable the object of one type to be substituted with the object of the derived type without changing the test bench architecture or even test bench code. So without changing the test bench code, we can able to override one type, that is derived type, to the actual type. Okay, that we can do with the help of this UVM factory. Once you register to UVM factory, you can able to override a particular type with another type. The base type can be override by the derived type. That we will see how we can do that. Then next point is user defined object and components can be registered with the factory via type for macro invocation. So we have to register the components and object to the factory. Okay. So how we can do? By two ways we can do. One is by type def. Okay, another one is macro invocation. So here in slide, in forthcoming slide, I am going to explain how we have to register the components and object to a factory with the help of macro. So if we use type def, we have to register like this. So class, for an example, I gave here. Class scoreboard extends UVM component. So type def UVM component registry. So UVM component registry is a class available in UVM factory. By help of type def, we are registering this scoreboard. Okay, this scoreboard as a scoreboard type by type ID. Okay. So this type ID is a separate function, static function is available. There we have a get method. Okay, so some certain value for the type ID will be assigned internally. So instead of doing this with the help of macro, we are registering the components and object to a factory that we will see next slide. So next part is using factory involves three basic operations. One thing, registering object and components to the factory, and using factory to create components and objects. Then third point, configuring the factory with type and instance override. So we are going to see these three processes of the factory. So now we are going to see about registering component and object to a factory. So here I am using macro method. So to utilize this macro method, before we start to code this, we have to include the macro. Okay. Tick include UVM macro .svgs that you have to include so that you can able to utilize these macros. So here class packet extends UVM object. So this is an object. Okay. So here class packet I am creating this one. I have to register to the factory help of this macro. Tick UVM object details is a macro. By using this macro, you can able to register this packet to the UVM component registry. Okay, this is available in UVM factory. So if you use a parameterized object class packet, it is a parameterized class. Okay. It extends UVM object. So how we have to register this packet to a factory means with the help of tick UVM object parameters. It is a normal type and just give tick UVM object details. It's a parameterized class. By using tick UVM object parameters, you have to pass the name of the class and what is the type we are using here, the parameters. This is for object. If I want to create a component, okay, I am create a class form extends UVM component. So for this UVM tick component details is a macro available to register this component to the factory. So tick UVM component details this name comp. So automatically this comp will be registered to the UVM component registry, a type of comp, and a type ID will be internally assigned to this type comp type. Then parameterized component. If it is a parameterized, similarly how we write for the object, the same way tick UVM component parameters you have to mention to register this comp to the factory. Next, now we register our component and object to a factory. Okay, next step, we need to know how to create a component or an object by using create method. So in system Verilog, we used new of, right? So create an object for a handle. Okay. Here in UVM, we have to use a create method for creating the object for a handle. So if it is an object, there are two types, right? One is object, another is component. If it's object, you have to mention the handle name equal to class name. So and I will explain this example. So this is a general syntax: handle, class name, scope resolution, type ID, scope resolution, create, and the handle name which you are creating. Okay. So if it is a component, you have to mention same handle, class name, scope resolution, type ID, scope resolution, create, and handle name. Along with this, we have to pass the handle where we are creating this handle. Okay. This scope we have to pass. So for example, this is a sequence item. Okay. Class simple transaction extends from UVM sequence item. From UVM sequence item, I am creating a simple transaction. So transaction consists of fields or properties. Okay. So this is an object, right? So this should be registered to the factory by using the UVM object details name of this transaction, simple transaction. So this simple transaction is registered to the component registry, the type of simple transaction, and a type ID will be created for it. So these are the properties of this sequence item. So now in the sequence, I am going to call this sequence item, and with the help of this sequence item only, I am going to create the sequence. So first I have to write the sequence, class sequence. This extends from UVM sequence. So sequence and sequence item both are object type. So tick UVM object details. I am registering this sequence to the factory with the help of this macro. Tick UVM object details sequence. Then I am instantiating this simple transaction. Simple transaction trans. Okay. So I created a handle. Now I need to create a object for it. So in function built phase, so tomorrow we will discuss about phase concept. So in built phase, I am creating a object for it. This is general syntax. Okay. So this is nothing but the handle name trans equal to simple transaction is nothing but the this name simple transaction we register, right? So for the simple transaction, so for this type a type ID will be internally created in the type. Here why we are using scope position means this type ID and create method all are implemented in static method. In component registry class, if you see everything, these are static methods available in the component UVM component registry class. Okay. So in simple transaction scope position type ID, scope position create, we are passing the handle name trans. So automatically that sequence item, okay, object will be created. So here in sequence item, this field or property also to be registered with the factory with the help of the macro, so that you can able to effectively utilize the methods clone, pack, unpack, compare, record, copy, print, those methods. It will support. These fields will be, if this data address, these fields, if you want to support these methods, okay, these methods, you need to register the fields or the properties to the factory with the help of this macro. Tick UVM field. This star indicates anything, that is it may be a int data type or string data type, enum data type. Okay. Tick UVM field int within the bracket that field name. For example, if it is address or data, you have to mention data, comma flag what we have to mention that I will explain next slide. Okay. So here, based on the data field type, we have to mention the data type. Okay. For example, these are the macros available. If I use a string property, I have to use this macro tick UVM field string. Within bracket, I have to mention that variable name, comma, that flag. Okay. So these are available string, int, string, enum, real, object, event. The same way for arrays. If I use any array or queue here as a, inside the sequence item, so this should be use this macro for registering to the factory. TQM field array int, TQM field array object, TQM field array string. If it is a queue and it is an int type means we have to use this. So in the same way, every macro is available. So this flag argument, we have to mention UVM all on. Okay, if you give flag as UVM all on, it will set all operator on. all operations, in the sense these all operations: print, copy, clone, compare, unpack, record, everything we can able to use. UVM default, if you give, it will take the default flag. In that, some of the settings, some few methods will be disabled. Okay. UVM no copy. If you give UVM no copy, copy function will not be work for that field. Okay. So UVM no compare. If you want you this variable or this field should not capable to do compare function when you declare UVM no compare. When you set a flag as UVM no print, you are not able to print the field or the variable which is registered to that macro. So UVM no def print. Do not print the field, it does not change. That means you want to set the flag as UVM no def print. UVM no pack. So if you do like this, you are not able to do pack and unpack with that field. And you can also mention the radix UVM pin. That means during the print and record the field, it should be printed in the binary format. UVM decimal, UVM unsigned, UVM octal, UVM hexadecimal, UVM string, UVM time. These are available. These should be mentioned in the flag. So if you didn't mention, if you are mentioning UVM all on, so default the value will be printed in hexadecimal. So this is one example. Usage of field macro. It is a sequence item. I am creating class simple transaction extends UVM sequence item. So these are the fields I am using: address and data. Okay. So these fields should be registered to the factory. So this simple transaction also registered to the factory, right? So by using tick UVM object details, we are registering to the factory. So here I am using begin end to add these fields also inside the factory registration. So tick UVM object details begin. It's a simple transaction type, and within the tick UVM field int. Okay, field is integer type, right? So bit it is also integer. So integer address comma flag is UVM all on. So you can able to do these operations. It will support all these operations. Then tick UVM field int data tick UVM all on. So now this sequence item, this object, okay, and also the fields which are present inside the object, everything is registered into the factory. So default constructor. So default constructor is in UVM component and UVM object. Constructor are virtual methods. That means if you see function new will be default available. Okay. In system Verilog also the new function will be available in default. So there, if I want to add anything while I creating the component, I will explicitly mention function new and function inside that I will mention a equal to 10. So while creating that, while creating the object for the class, automatically a value will be assigned as 10. So here in UVM, this function new will be defaultly available, but in the latest version UVM 1.2 version, it is mandatory to mention the new function explicitly, and we have to call super.new. Super.new, that means new function which is available in this parent class. So it will call its parent. Okay, let's see this one. The UVM component and UVM object constructor are virtual methods. That means new constructor. Okay, that are virtual methods. So here in this UVM 1.2 version, we have to explicitly mention this function new while you create or you are writing a object or a component. For example, it is a component class. My component extends UVM component. So this should be registered with the factory that we have to do. Okay. So take UVM component details, my component that you have to write. So and also we have to write this one function new. Okay. We have to pass when we are declaring component. We have to pass two arguments. One is name of this component, string name my component, and UVM component parent is null. If it is a top level component, we have to pass null. Otherwise, we have to pass the handle, where we are creating this uh, component. Okay. Usually, we pass this. Okay. So this is passed to the super.new. So super new method defaultly it is available. So which one is its parent? My component parent is extended from UVM component. So the UVM component have its inbuilt new function. So it consists of two arguments. One is the name of the component and parent handle. Okay, so it will receive. So what is the parent of this UVM component? UVM object. So it will pass the argument to the UVM object. Okay. So this hierarchy will be created in build while building the test bench hierarchy. So automatically the hierarchy structure will be created, and also you can able to use, for example, UVM component new function. There are some logics will be implemented. Okay. So when you call the superlative, automatically that logic or concepts will be implemented in that. So it will use it to create the test bench structure, hierarchy structure. So if it is an object, class my item extends UVM sequence item. So it is an object, right? Sequence item. So here also we have to write the explicitly we have to write the function new, and we have to pass only the name of the object, my item. So internally we have to call super dot new name. So it will call its parent class UVM sequence item. So internally it will call UVM sequence as a UVM transaction. So here this is a dynamic in nature. Okay, during the simulation it will create and it will send. It will we are forcing this DDAT. Then next transaction will be sequence item will be created. So it is not a constant one during the simulation. So no need to pass the handle. Okay. So for UVM component, you need to pass the name and the handle where we are creating, and UVM object we need to only pass the name, okay, of the object. So it is mandatory for each component and object what you are writing. Once you write that, you have to register that to the factory by UVM component details, and if it is object, UVM object details you have to register, and you have to write the function new constructor explicitly to build the hierarchy structure for UVM component, and also you have to write the function new for object to create its object to connect with the top level hierarchy of the object. Then overriding we are going to see. So I already told three things we are doing in factory. First one is we are registering to the factory. Second thing, we are creating a component object by using create method. And third one, overriding the type. Okay. So here overriding there are two types. One is type overriding and instance overriding. So type overriding means globally it will override. One type is override by another type globally. Okay. So inst override means on particular instance we can able to override by inst override. Okay. So this overriding we can do in two ways. Okay. One is with the help of registry wrapper method. Okay, I'm going to explain the registry wrapper method. Okay, in UVM component registry, we have it is in subclass is UVM registry wrapper. Okay, so in that we have a method. With the help of this method, you set type override and set inst override. With the help of this, we can do the another method to override. We can use component factory method. So factory we have a method like set type override by type and set inst override by type. By using this method also we can able to override. Okay. So here set type override by type we have to mention the original type and override type. Okay, this will override this one. Inst override means we are going to override a particular instance, right? So that path we have to mention where is the original type is available. That path we have to mention and the original type and override type. So this override type will override the original type which is mentioned in this path. Okay. So now we are going to see about the registry wrapper method. Using the registry wrapper method, how to override the particular type to another type. So type override, every time a component class type is created in testbench hierarchy, a substitute type that is derived class of the original component class is created in its place. It applies to all the instance of the component type. So here base type and derivative type is there. So I am going to override the base type by using my derived type. Okay. So that this general syntax is original type we have to mention here. That is base type, type ID, set type override. It is a method available in UVM wrapper, UVM-Part registry wrapper. Okay. In that it is a method available. Set type override. With the help of this method, I have to substitute type. Substitute I have to mention here. Using get type, I can able to get this type. Okay. And I am going to override this original type with this derived type or a substitute type. So this replace is argument, it is optional. The default this replace value is 1. When it is 1, it will override the original type. If you explicitly mention replace equal to 0, it won't override. Then instance overriding, it substitutes only a particular instance of a component or a set of instance with the indented component. The instance to be substituted is specified using UVM component hierarchy. So only a particular instance I need to override means I go with this method set inst override. Here I use set type override or I use set inst override. Same way original type ID, set inst override, the substitutional type, get type. Then here I have to mention the path where the instance is present, particular instance which I am overriding. Right? So that one I have to mention here. Let's see one example for this. So class my driver extends UVM driver or UVM component you can use. So UVM driver is derived from UVM component. So directly you can use UVM driver. So this is the base class. So once I create this one by using tick UVM component util macro, I register my driver to the factory. Then I am deriving my updated driver. Class my updated driver extends from my driver class. Okay. So here also I register my update driver to the factory with the help of UVM component tools. So here I am updating. There are some additional features I am adding. Okay. As per my design. This is the basic one. And here I am adding extra segments. So here in agent is top of the driver, right? So in agent, my agent extends from UVM agent. So this my agent should be register to the factory with the help of tick UVM component details. My driver, I am instantiated this my driver as a drvr. Okay, so I have to write the new constructor. Then in build phase, okay, build phase, I am creating the object for this driver handle. drvr is a handle. I am creating object for this by using create method equal to my driver. Okay, inside that I have a type id. Inside that I have a create. I'm calling that function create method and I am creating object. Okay, with the name drvr, and it is a component, right? So we have to pass from where I am creating this one. This means this represent from agent I am creating this one. So in test, so you should know the UVM test bench architecture. Okay. So test is the top level. Okay, I already explained that one. So test, we are instantiate with the test. Okay. So test will instantiate, and below that we have the environment, and then below that we have an agent. And the agent consists of master, sequencer, and monitor, all those things. So inside the test, okay, it is extends from UVM test, and this test should be registered to the factory. Inside that, I am instantiated environment. So function new constructor we should write for the test, and then build phase. Inside the build phase, here what I am doing here, I am doing the overriding process. Here for this particular test, okay. So there are different tests. For this particular test, okay, I want to use my updated driver. Okay. So there are two drivers. One is my driver, another one is my updated driver. In this test, I need to use my updated driver instead of my driver. Okay. So in driver, if you see in the agent, I instantiate the driver only. I instantiated my driver, okay, drvr, and I create a object for my driver only. But in this test, I want to use my updated driver. So what I am doing, I am doing overriding here. My driver is the original type. Okay. Scope resolution type ID. Scope resolution set type override. Okay. Set type override means everywhere it will change for this test. Okay. Which one I have to? My driver should be override by my updated driver. So my updated driver scope resolution get type. So I will get this type and I will override this my driver. So this is what default. So after that I am creating the environment by using create method. So in the below of the test I have a env class. So that should be registered to the factory. So in test is one hierarchy above to the environment. So here I instantiate the environment and I am creating the environment here. So automatically inside the environment we have an agent, this one. Okay. So when agent is created, it will create a driver. But here I override it, right? So automatically instead of my driver, my updated driver will be processed here. Okay. So then in run test we have to implement running the concept which we are going to use. Then here the point is you should write this override method before you create the environment. If you put this env create method before the override, so that environment will be created with the normal my driver. Okay. So I need to use my updated driver, so that you have to override before creating the environment. So if I want to do instance override, the same way in the build phase, how in the build phase of the test, okay, build phase of the test, instead of this set type override, you have to use set inst override. So my driver type ID set inst override, and the actual so override substitutional type, and the path we have to mention. Where is this drvr is available? It is available inside the agent. This agent is available inside the environment, and it is available in the tab. So the whole path you should mention when you go with this instance override. So this instance override will not applicable for objects, okay, because so objects, it is a if it is a component, it is a static, okay. So if this component we can able to use in many forms, but the objects will be, yeah, in a particular form. So we can able to do type override for object. Instance override is not applicable for objects. Then debugging the UVM test bench structure and factory content with the help of this print, okay, inside inside the test class, in the end of elaboration phase can use this dot print. So this will print the structure of the test bench in tabular form. So the whole structure of the test bench will print in the tabular form when you use this dot print in the test bench in the test. And to query the type that were registered with the factory. When you use factory dot print, it will display what are all the components and objects and fields which are registered to this factory. So that you will get when you use this factory dot print. So this will helpful to debug whether this overriding happens properly or not, or what are the components and objects which is registered to the factory, that you can able to see when you do this factory print. Okay, this is the overall operation of the factory. So here I am creating a component A, class A extends UVM component. This should be registered to the factory with this field macro. So when I register this to when I use this field, this is a macro, right? This is not a field macro. When I use this unique UVM component this macro, so automatically it will register to the UVM component registry. Okay. So this will be A is a type. It will register here. So inside that UVM registry there is a get method. In the type ID there is a get method. So this will call the register which is available in UVM factory. In the register, it will assign the type. Okay. So type ID and it's a type A. Okay. This will be happen. The same way I am creating a object class B extend A. Okay, I am extending B from class A, and I am registering this to a factory by using this macro, even component fields. The same way, get method of B in the UVM component registry will call the register, and B will be loaded to the registry, okay, array register. So in test, what I am doing, I am overriding A type ID set override B. So instead of A is overridden by B. Okay. So instead of A, I am going to use B in the environment. So when you do this set override, automatically set override type. So it will call set override by type, which is available in UVM factory. So it will assign A and B are same type. In a override view, it will put A and B. Okay. So now A and B are same. Now the next in the test, I instantiate environment, and inside the environment I am using create method. I create an object for A. Okay, when I create object for A, create method will be called. Okay, this method called the create component type. Okay, so create component type. So A here A is nothing but a B. We are already mapped. Okay, so create component of B will create B, and it will send to here, and it will create B instead of A. So this is the overall process happening. So the main thing, by using factory during the runtime without changing the code of the test bench, we can able to uh, we can able to override one type to another. Okay, based on our requirement. So for example, I have two agents. Okay. One is supported for APP protocol. Another one is supported for AXI protocol. Okay. So I want to use my agent 2, which is supported AXI. Okay, I want to use with APP the driver. I want to use that as APP driver. Okay. So I can able to override if APP driver XI driver is extends from APP driver means. Okay, so I can able to override the XI driver with the APP driver. Okay, so during the test I can able to change. I need APP driver instead of XI driver. Okay, I can able to override that, and I create a new function, and I can able to drive my stimulus through that driver. So this will be helpful in that way. So here in factory, there are three operations. One is one, you should know how to register to the factory. So by using component utils, you are registering component to the factory, and using UVM object utils, you are registering object to a factory. And if you want to override one type to another type in test, you have to override. We can do in two ways. If you want to override completely, you can use set override by type. If I want to override a particular instance, you have to use set override, sorry, inst override. Inst override that we have to use. Then you have to create. If you register component or object to a factory by using create method, in the top hierarchy, you can able to create a particular object or a component. Okay, these are about factory concept.